Right. His name is Vector, and I should have pulled the quote up from the movie, but I didn't. He describes why his name is Vector in the movie. Basically, he defines the word vector. He says something about magnitude and direction. I don't know. I don't remember. We have to look up that quote later. Maybe I'll do it at the end of the notes. But have you guys heard of a vector before? Besides vector, have you heard of a vector? 2 people have. Excellent. So a vector is a quantity that tells you direction, and it tells you size, which is magnitude. It's represented in a coordinate plane by an arrow drawn from one point to another. So here's a picture that looks like a vector. And this diagram shows a point, P. That's going to be the starting point. Do you know why I know that one is the initial point? Does anybody know why I know this one's the initial point? What? Does it have an arrow? There's arrows going away from it, right? So this has got to be the starting point. It's kind of like a ray. And then my terminal point would be the ending point, terminal, which is going to be Q. And we name the vector PQ. Now this is really hard to show. It's hard to see. We don't have the best printing capabilities here. So I'm going to show you bigger what it looks like. It looks like PQ, and then right above it is a half arrow. That's what vector symbol is. Okay, that's what this little thing is right here. It's a half arrow. We read this as vector PQ. The horizontal component is how far does it go right to left, left to right? It goes 5 units to the right. That's the horizontal component. They say the horizontal component is 5, and the vertical component is 3, because we're going 3 up. And then the component form combines the horizontal and vertical components. So the component form of vector PQ is, we use a chevron, which looks like this, 5, 3, and then another chevron. So it is not an ordered pair. It is a vector that tells you size and magnitude. I mean, size is magnitude, direction and magnitude. Bless you. So in the diagram, name the vector and write its component form. So we look right here. What is the starting point? P. How do you know? Does not have an arrow. Ryan, what's the ending point? How do I know? Because it has the arrow. Right up, we're going to put the little vector symbol. So that's naming it. And then we have to figure out the horizontal component. So I'm going to look, how far horizontally are we traveling? Now this is a tricky one. So I'm going to call on David. You're almost right. How would I know which 4 we're going? How would I know left or right? If I say 4, how do I know if I'm going left or right? Because I want to go left. What do you think? Because up here it was 5 and I went to the right. So 4 should mean right. How could I make it mean left? Avneet? Make it -4. Because we're going to go left 4, right? Correct, Timmy? So I'm going to start with my horizontal component at -4. And then from there, we're going to do our vertical component, which is, Aaron, what is that? 5. And is that positive or negative? Why? Because we're going up. Excellent. Okay, Raylan, can you name this vector? I don't think it's a J, but yep, JK. JK. That's okay. Vector JK, we have that funny little thing above it. Emily, can you help me find the horizontal component? Is that going to be a +3 or -3? Okay. for positive 4? Yes, good. Excellent. Can we handle that? All right. Here's some more vocab that you hopefully went through at the beginning of class today. A transformation is a function that moves or changes a figure in some way to produce a new figure called an image. Another name for the original figure is the pre-image. The points on the pre-image are the inputs for the transformation, and the points on the image are the outputs. Oops, my nose on the back. And then this, to me, looks super confusing. I'm going to try to break it down. It's a little bit easier if you look in the book on this page because it's in color. Actually, I probably have it open. A little bit easier to see because it's in color. So you guys can look at yours, but look at the color one on the board. A translation. A translation moves every point of a figure the same distance in the same direction. More specifically, a translation maps or moves the points PQ of a plane figure along a vector AB to the points P prime, Q prime, so that the following statements are true. Okay, so what it's saying is my original figure, what's the original figure called? Jay, what's the original figure called? No, the original figure, it's on the previous paragraph on the front of the page at the very bottom. The original figure. Pre-image. How can we remember the original is the pre-image? The word pre, that means before, right? Before anything happened. So here, my pre-image is this segment PQ. And then what's the second one called? What's the second one called, Donovan? Like the transformed one. So if the first one is the pre-image, what's the new one? Good guess. It's on the front. It's not. It's on the front. Last paragraph on the front. The transformation is what happened, but after the transformation happens, it's bolded. There's 3 bolded things in that paragraph. Image. Yeah. So post-image was a good guess, but it's just image. So we've got our pre-image, we've got our image. Now I totally want to call it post-image. Image. To get there, we're going the same direction and the same distance. This is a translation. You can think of it as sliding. It is a translation, though. That's the words we're going to use as translation. Okay. And then it has some more information that says that the P to P prime is the same. Ooh, I'm using the word prime. Do you know what I'm talking about? Probably not. Do you know what I'm talking about when I say prime? Yes or no? No. Okay. So when I write this, we say this. It's P prime. And then this is the symbol that tells you it's what happened, the image symbol. So I'm writing, this is the symbol, or the symbol right here. This is the image of P. The symbol tells us that this is where P went to. So you look at the picture, the original P is here, the pre-image, and then over here is P prime. So that's where P moved. Because you won't have all these arrows and all that stuff when you actually do it yourself. So Q is the pre-image, Q prime is the image. So here we have vertices of, ooh, what's this say right here? Anybody know? Rakai, do you know what this says right here? Yeah, triangle. Good guess. Triangle, ABC. The vertices of triangle ABC are at 0, 3 for A, 0, 3, A. 2, 4 is B. And C is 1, 0. So you're noticing I am graphing these. And we have a triangle. Translate triangle ABC using vector 5, -1. So remember, the first number 5 is which component? Jesse, which component is the 5? Is that horizontal or vertical? You can use intuition. Like when we graph ordered pairs, we always go X and Y. This is our X axis. This is our Y axis. So what do you think comes first? Because X is the horizontal axis, so this is going to be the horizontal component, right? So this is telling us 5. Matthew, what does 5 mean? Okay, so I'm going to look at point C, and I'm going to move 5, 1, 2, 3, 4, 5 to the right. Is that where the C prime goes? No, because why, Lynn?
There's still -1.
Oh, we still have a vertical component that says to do what with C? Down 1. So that's going to be C prime. See how I label apostrophe, C prime. Now I'm going to do the same thing to A and B. I'm going to move each of those 5 down 1. And you will notice that this does not change the shape, it does not change the size, it does not rotate it, it does not reflect it. Exactly over here. Translation. There's one for you to try. It's like the directions are down here. I was trying to save paper. Oh, it's the same. It's the same triangle. So that should be easy to graph it right away. You okay? Make sure you are labeling your points, especially with the primes, because especially when it's something new that you've not done before, you will not remember it unless you do it. If I do it, you should do it. Right? If I do it, you should do it. Right? If I do it, you should do it. Okay. Example 3. Write a rule. So you haven't seen this yet today, so if you're writing your rule, write a rule for the translation of triangle ABC to triangle A prime, B prime, C prime. First of all, what are these called? These things separately. I'm looking for a vocab word that we learned today. Ryan, do you have an idea of what I'm talking about at all? Yes. Which one?
The ABC.
No. Because what's the other one called? If one's the image, what's the other one?
Pre-image.
So which one's the pre-image?
Triangle A.
Right. So this one here is the pre, which makes the image the one with the primes. Triangle A prime, B prime, C prime. It's usually, I think, helpful to think of the word pre-image first and then think of the word image. So this one's in color too, if it helps you at all. Where is it? This one? Yeah, this one right here. Okay, we're going to write the rule. Whoop. There we go. Find the component form of the vector, but that's not going to be our answer. But it might help us find our answer. So I saw some of you already writing this down. If we're starting at A and going to A prime, which direction am I going? Left and up. So how far to the left? 1, 2, 3, 4. -4. And then we go up 1. So this would be the component form. This is how we write the rule. We start with every ordered pair, and then we draw an arrow, and it says what's going to happen to these ordered pairs. What are we going to do to the x's? We're going to subtract 4 from all the x's. What are we going to do to the y's? We're going to add 1 to all the y's. So this is the rule. Start with this ordered pair, end with this ordered pair. Okay, this here is called the rule. This over here is the component form. Okay? So there's a you try. You try to write the rule for the translation of triangle ABC to A prime, B prime, C prime. We're writing a rule. Does it matter which point I look at? Alex, do you think it matters if I look at A or look at C? Will I get a different answer? What if I look at A and I go to B prime? Yeah, I would get a different answer then. But we want, obviously, A is going to go to A prime. C is going to go to C prime. It doesn't matter which one you look at. So our rule is going to start with x comma y, arrow. What are we doing to all of our x's? Maggie, what are we doing to our x's?
We are adding 2.
Yeah. Cameron, what are we doing to our y's? Perfect. So that's what you're going to write down for your rule. All right? Almost done. Graph quadrilateral ABCD and its image after the translation xy goes to x plus 3, y minus 1. So we're going to graph quadrilateral ABCD.
So we don't, for the rule, we don't have to put like A is this coordinate and
Nope.
So we
So
just have to put like,
this says for every single ordered pair, we're going to do the exact same thing.
okay, so that's just the answer. We don't
Yeah,
have to
this
do
is the
that.
rule. This is like the general rule for every single ordered pair for translation. So -1, 2 is A. -1, 5 is B. C is 6. D is 4, 2. And I gave you these like 10 by 10 graphs, so it might take you a little bit less time to graph. I try to keep them all the same so you guys get used to the 10 by 10s and it's easier. Oops, I forgot to label though. C, D. J. What am I going to do to the A point to find the new A points?
Add 3.
To the, perfect. So I can do that without even having a graph. All I have to do is take my original ordered pair, -1, 2, and then add 3 to the x's, take away 1 from the y's, and I get A prime is what? 2, 1. I can also do that on the graph by going left 1, up 2. That's not right. I looked at the wrong thing. Sorry, I looked at this. I can also do that on the graph by going right 3, down 1. There's my A prime. This guy is a mistake. So I could do that with point B as well. Point B is -1, 5. I can take -1 plus 3, 5 minus 1, and I'll have B prime. 2, 4. Or I can just stay on the graph. Add 3, take away 1, C prime, D. Add 3, take away 1, D prime. So I just showed you 2 different methods that you could use to find these answers. Okay, I want you to try question B. You can try it by just finding the numbers and then graphing them, or you can try it by just taking each number and translating on the graph. Okay, some of you still have your computers out, some of you do not. I want to show you where your assignment is. Tonight your assignment is on Big Ideas Online. Your assignment is not on paper. So I can't log in as a student to show you. I can kind of show you what it looks like from my side, but it's different. At the top, some of us have this open. At the top, there's like assignments. You know, resource assignments and reports. You guys have the same thing on yours. If I click on assignments, mine looks totally different than yours, but yours will look something like this, and it'll say something like enter. Yes? Not today. But thank you for asking. Nope, today is just, they're going to have you graph on the computer. You actually touch the computer and graph stuff. We will do some things on paper so you've practiced both ways, but that's where your assignment is tonight. Okay?